In the early 1980s, Heathkit released a number of new products, many of them multimeters, digital multimeters, which could either run off of internal NiCad batteries or internal alkaline batteries. I think they all used the C size except one of them. They always tallied 9 volts DC for the batteries. And some of the part numbers that worked with was the IM-2215, which was a handheld digital multimeter, the IM-2260, which was a benchtop digital multimeter with LED display, and the IM-2262 and IM-2264, which were LCD display versions similar to the IM-2260, with subtle differences between them all in regards to features. These all could use a Heathkit part number PS-2350 power supply and battery charger. The IM-2215 used a 9-volt battery and was not rechargeable. The other models were rechargeable, but they all could use the same PS-22 or 2350 power supply. Its specifications, as near as I can tell, were 9 volts DC. I don't think it was regulated, but it might have been. I haven't found any information on that. And good for at least 100 milliamp output, maybe more. I have acquired several meters in that line. I've already done a video on one of them, the 2215. And the other ones, so I don't have to load them up with C cells, I'm planning on running them off the AC adapters. But I could not find a PS-2350, so I'm going to make my own. And I'm putting this up primarily in case anybody else has an old Heathkit that needs a 2350 power supply and maybe is wondering what's a good way to make one. Not being entirely sure of the maximum current the power supply would need to provide, I went with this part number obtained from DigiKey. This is made by XP Power in Cambodia. How about that? It's a 9-volt regulated switching power supply, AC-DC wall adapter or wall wart, 5 watts, and that comes to a little over 500 milliamps. So it should be more than enough for any of the models that would use the PS-2350. This is the DigiKey part number up here, in case any of you playing at home want to get the same power supply. And here that is, just a small, fairly typical switching power supply wall wart. Naturally, it does not have the vintage style plug on it. It just has the what's today the ubiquitous standard barrel connector. That's going to have to come off. And instead, it uses what was then a popular method of connecting wall warts to equipment, and that was a 2.5 millimeter tip sleeve phone connector. So very similar to the 1/8 inch or 3.5 millimeter phone plugs that are used for headphones on Walkmans and all sorts of other things these days, but it's smaller. Instead of 3.5 millimeter diameter, it's 2.5 millimeters. And I think that comes to about 0.1 inch in diameter, which is what it probably would have been called in those days. Now this is a pretty good quality one. This is Switchcraft, I believe. I'll verify that here in a second. Here's the bag from DigiKey. Yes, it's a Switchcraft plug, and that's the DigiKey part number. Somewhere on there is the manufacturer's part number. I think it's right there starting with the 12. Heathkit specifications don't say it, and none of the meters that I've acquired are clear on their markings as to whether it's positive center or negative center. So I took a 2260, IM2260, and just sketched out the schematic of the input power and verified that the sleeve of the phone connector, that would be this in my schematic, is connected to the negative side of the battery. Therefore it's a positive tip, and therefore it should be a pretty simple matter to just solder this up. I'm going to do that now. With the power supply plugged into my power distribution center, I wrung out the stripped leads after cutting off the barrel connector to verify which side is positive, and it looks like the side with the stripe, the white stripe that is, which is bottom in this view, is the positive. And there's the plug with the wires soldered on, and of course I remembered to put the shell or housing on first. And by the way, this is a machined and black anodized shell, not the usual cheap plastic ones. Count on Switchcraft to do a nice job in that regard. And there's the plug on the end of the cord. Wish it would focus a little better. I just did a check to verify that I did get the polarity right, positive center, and 9 volts coming out of the supply. Alright, so here's a Heathkit IM2260 that I'm working on, and this is the back panel, and this is the battery holder for 6 C-size alkaline or NiCad batteries. There's a jumper on the circuit board that determines whether the circuit will try to charge the batteries or not. Obviously, if you put alkalines in there, it's not going to try to charge them if you move the jumper accordingly. And there's the unmarked power jack. It doesn't say anything about, this is where power comes in. For all you know, looking at this, you could plug in something and get a test tone out of it or something. But it is the power jack. And I've got my newly made plug. Let's see if I can do that. So it's plugged in there very nicely. And let's see if it turns on. Yay! So that, my friends, is how you build a Heathkit PS-2350 wall wart power supply clone. Hope you found this to be interesting.